Hi and welcome to this video lecture. In today's lecture I will go through superposition in quantum mechanics. So superposition describes states, how things can be in a bunch of different states at the same time. So it is helpful to think of states as vectors. So if you have a vector x here in this direction and a vector y in this direction, the vector z here is a superposition of x and y. You see? Yeah, somewhat correct. Yeah. So the vector x here, z here, is a superposition of x and y. So why it's helpful to use vectors to describe states is because vectors can be added together to create other vectors, and you can describe a vector in different ways, and I will get into greater detail about that soon. So if you have a beam of light right here and you shine that into this magic box, this magic box is called a beam divider. Essentially all it does is divide the beam into two equal parts. The light beam in two equal parts. So one beam will go into this direction and another will go in this direction. And here you will find two mirrors. Mirror 1 and mirror 2. And these mirrors will reflect the light and to another point. So they will get reflected to another magic box, which is also a beam divider. And this beam divider essentially will divide these light beams yet again until they face a detection scanner or something, something that detects the light, D1 and D2. And this is beam divider 1 and this is beam divider 2. So this is a system. You shine light through a beam divider that splits it into two parts. These two parts get reflected by one mirror each until they are collected into this box and then divided yet again. So the problem here lies that if you were to shine light through here, you will of course have interference right in this point. So what is weird here is if you only were to shine one photon of light at a time, you will still get interference. So the explanation for this is if you have two photons and you shine them at the same time, you will of course have interference. And there is two types of interference, constructive and destructive. So if you have two photons, two individual light beams, they will interfere, most people will say and think. But if they were to interfere, if you would have destructive interference, you will have a bunch of energy that would cancel out into nothing. And that is not really how energy conservation works. And on the other hand, if you have constructive interference, you will always get 4 times the amplitude, since it's proportional to the squared. So you will get 4 times the energy from two photons. So that does not make a lot of sense. So the only way, I know it sounds strange, to have interference with photons is if they interfere with themselves. And the only way for that to happen is if they go through both of these beams at the same time. So somehow this photon passes through both beams and are collected again in this point here and then divided again. And that is called superposition, when something can be in multiple states at the same time. And when you measure it, either you will get a measurement in D1 or D2, and that is just a probabilistic way. since you observe the system. So the quantum mechanical state for this can be described as you have a certain probability, the eigenvalue alpha, of it going into the upper beam, and another probability beta that will pass through the lower beam or the down. So this is the upper beam and this is the down beam. So if we continue on this way of writing states, we'll do that again. So here you have two vectors. You will have vector B and vector A. Oh, sorry, that is not supposed. It's supposed to look like that as well. So alpha and beta, they are of course complex numbers, and what I mean by that is they follow this formulation that the complex number z is equal to x plus iy, where x is a real number, y is a real number, and I is of course the square root of -1. Let me just adjust that for you. The square root of -1. So if you were to measure it, you will have a certain probability for A that is proportional to alpha squared, alpha norm squared. And if you decided to measure B, for example, that would be proportional to beta norm squared, since these are called probability amplitudes. And you need to square the probability amplitude in order to find the probability of finding a particle or something in a given state. So to find a state, you need to take the probability amplitude, alpha and beta, and norm square them. So in quantum mechanics, you can only have one or another. If you were to measure this system, you would only find A or B. This is the sorry. You will only find A or B, not a combination of them, not an average of them, nothing like that. You will only find A or B. And that is a bit weird, because things are governed by the complex number, the eigenvalue, the probability amplitude. So the whole universe, as it seems, is governed by probability amplitudes. So for example, if you find your state to be A, the entire system have now collapsed to become A. And if you measure your state to be B, then your entire system is now B. So if you were to conduct an experiment in quantum mechanics, what you need to think about as a physicist is that you have to redo your experiment multiple times and prepare multiple states, multiple copies of your state. Because as you can see, the state, the quantum mechanical state, is a combination of different superpositions. And these superpositions have a certain probability amplitude to occur. A certain probability for them to actually occur in the real world when you are measuring it. So if you want to find if you were to conduct an experiment where you were to try if you would find B or A, you need to redo the experiment multiple times, because sometimes you may get B and sometimes you may get A. And that is a bit dangerous, because if you only do the experiment in a classical way, we do it once or twice, you may only find A or B. But if you redo the experiment a finite amount of times, where you actually see that you have a combination of both A and B, that is when you actually can say that you have found a result. So thank you for watching this short introduction to superposition. I hope it was helpful. Hope to see you in a future video.